Alright, so today we're going to be doing dividing rational expressions. Alright, so dividing rational expressions is kind of almost basically like multiplying, except one quick, easy step that you have to do. Alright, so when dividing rational functions, you multiply the first fraction by the reciprocal of the second fraction. Then you simplify where you can. Whoops. And then we call this the same change flip. Actually, you can call it same change flip. I go between same change flip and keep change flip. So there are steps, and like I said, it's one extra step. Okay. The first thing you have to do is factor completely the denominator and numerator, which is the same first step as multiplying. Then we do the keep change flip. You keep the first fraction, you change division and multiplication, and then you flip the last fraction. Then we go to multiplication rules. Cancel out any common factor pairs in numerator and denominator. Smush top, smush. It did it again. Smush top, smush bottom. Okay. And then we write new simplified expression. Okay. So we are going to just jump into examples. Okay. So same thing, same process, except you just have to change it to multiplication first with the same change flip, right? So the first one we're going to do, number 1, is going to be 7x to the 4th over 24y to the 5th divided by 21x over 12y to the 4th. Okay, so I go between, you can do this first and then this, or you can do this first, then this. It doesn't really matter which one you do first. So let's just factor it. 7's already prime. X to the 4th means there's 4 x's. 24 can be, let's see, that's 2 times 2 is 4. That's 8. That's 16. Let's see, now might have to do the tree on this one. 24 is 2 and 12, 2 and 6, and 2 and 3. There we go. So 2 times 2 times 2 times 3, and then that's 5 y's divided by 21 is 7 times 3, and then the x. 12 is going to be, well, we got that right here, is 2 times 2 times 3, and then that's 4 y's. Now, step 2 says to keep, change, flip. Okay? So you keep the first fraction. Change division to multiplication, and then flip the last fraction so the denominator comes the numerator. And the numerator becomes the denominator. And after you do that, then you can cancel like pairs on top and bottom. So you're going back to the multiplication rules. Okay, I've got 1x on bottom, got an x on top. I got a 7 on top, a 7 on bottom. I've got a 2 and a 2, 2, 2. It's kind of like matching. Now, it doesn't matter what 3. You could have done whichever 3 you wanted to. I've got 4 y's here and 5 here, so I can work all 4 of those out and just 4 of those. And then you smush. Well, I've got only 2 x's on top. And on bottom, 2 times 3 is 6. And then I have 1 y. And that's your simplified version. Okay, so the only thing new today is the keep, change, flip. All right. So number 2. Let's see here. Get my paper right. Let's see. So 2 is 3x plus 3 divided by 6x plus 12 divided by 18 over 5y plus y. Sorry, that's not a y, that's an x. Can't read my handwriting. All right, so first thing, factor. Remember, look for that GCF first. So like here, I've got a 3 I can pull out. So I'm going to pull out a 3. I'm left with x plus 3 divided by, well, 6 and 12 have a 6 in common, so I can pull a 6 out. That's going to give me x plus 2, okay, divided by 18. 18 can be 2 times 3 times 3 over, I can pull a 5 out over here. All right, oh, that should not be a 3, that should be a 1, my bad. All right, now, so that was all GCF factoring. Now this 6, can still be prime factored into 2 times 3, but we'll do that in the next step. So it's keep, change, flip. So I keep the first one, and it's going to be 3 times x plus 1. I'm going to change that 6 to a 2 times 3, and then it's going to be x plus 2. Change it to multiplication, and then flip. So the 5 times x plus 1 comes on top, and the 2 times 3 times 3 goes on bottom. Now, now we can cancel out any common pairs. So, see, if you had left it here, you would cancel that out. Can't cancel out anymore because it's on the same, so both on the top. But I can cancel a 3 and a 3, and that's it. And that's okay. Now, when I smush it, I have this. There's multiple ways to write this polynomial, actually. 2 times 2 is 4, times 3 is 12, times 3 is 36. So it's 36x plus 2. Okay, sometimes things don't simplify nice and pretty. All right. All right, so remember, if you have these two that are the same, I can write them as 5 times x plus 1 quantity squared. Just like when you have 2 x's, you can write x squared. Well, I have 2x plus 1s. And then on the bottom, 36x plus 2. You can put it in standard form if you want to. That's how I'm going to leave it right now. Okay? All right. We've talked about going to standard form, so you guys should know how to do that one. So number 3 is going to be x squared minus 49. Uh-oh. My hand. So x squared minus 49 divided by quantity x minus 7 squared divided by 5 times x plus, I don't know why I put parentheses there, 5x plus 35. I was factoring in my head. And then x squared minus 7x. Okay? So this, perfect square alert, 49. So the square root of 49 is plus or minus 7. So it's going to be x plus 7, x minus 7. This means there's 2 of those. So it's like going backwards. So it's going to be x minus 7, x minus 7 divided by, I can pull a 5 out. That'll leave me with x plus 7. Here, they only have an x in common, so I can pull an x out, so it'll be x minus 7. Now we have to do the keep, change, flip. So you keep the first numerator, and it's already in its prime factorization, so we don't need to do anything else to it. Change division and multiplication, and then flip the last fraction. So the denominator comes on top, and the numerator goes on bottom. Okay? So then after you do that, we are going to cancel out any like terms that are on top and on bottom. So x plus 7 is on top, x plus 7 on bottom. Got an x minus, an x minus. I got another x minus, another x minus. So the only thing left on top is the x, and the only thing left on bottom is the 5. And that's your answer. Okay? All right, number 4. Number 4 is going to be x squared plus 10x plus 16 divided by x squared plus 6x minus 16 divided by x plus 8 over x squared minus 64. Alright, so the first one, you can use Desmos to factor, or you can factor in your head. 16 and then 10 is going to be 8 and 2. So it's going to be x plus 8, x plus 2. Because 2 times 8 is 16, 8 plus 2 is 10. the denominator is going to be, it's also going to be 8 and 2, but it's going to be a positive 8 and a negative 2. Okay, because 8 times negative 2 is negative 16. And then 8 plus negative 2 is positive 6. Divided by, now guys, you also can factor and keep, change, flip too if you want to do that. Okay, but you know me, I show everything. So x plus 8 is already simplified. Perfect square. The square root of 64 is plus or minus 8. So it's going to be x minus 8, x plus 8. Ran out of room. So then we do the keep, change, flip. Keep, change, flip. So you keep the first half. Change division and multiplication. Flip the second fraction. And divide it by the numerator. We flipped it. Alright, after you do the keep, change, flip, now we're going to cross out like terms. Okay? So a like term would be x plus 8, x plus 8, x plus 8, x plus 8. And there's nothing else alike. So my final answer when I smush the numerator would be x plus 2 times x minus 8 over x minus 2. Now again, you can factor that top or full that top out and put it in standard form and get x squared minus 6x minus 16 all over x minus 2. Either or works. Okay? Alright. So again, either answer is the answer. Now, number 5, if you want to pause the video after I write number 5 down, this would be a good time to practice. And then hit play and see if you get the same answer as me. Okay? Make sure I read my paper right. Alright, so pause it if you want to try. Give it a shot, guys. Okay? Alright, so factor the top, or factor everything. So this factored, we'll go to Desmos for this one since we haven't done that one in this video. So when we type this one Desmos, we get x squared minus 5x, did it again, minus 5x plus 4. This one is factored at x, so that'll be x minus 1 and x minus 4. So x minus 1, x minus 4. Denominator perfect square, but you can also do that in Desmos too. X squared minus 1, right there. X plus 1, x minus 1. Another perfect square. The square root of 9 is 3, so it's going to, or plus or minus 3, so it'll be x plus 3, x minus 3. Denominator, you can factor it on Desmos if you want to, or you can just do it in your head, which is going to be x plus 4, x plus 1. Okay? Then we have to do the keep, change, flip. So we're going to have x minus 1, x minus 1 times x minus 4 over x plus 1, x minus 1, change division and multiplication, and then flip that last rational expression. Alright, after that we are going to cancel any common factors out on top and bottom. So I have an x minus 1 and x minus 1, an x plus 1 and x plus 1, and that's it. So this is going to be smush the top, x minus 4 times x plus 4, all over x plus 3, x minus 3. So those are differences squares right there factored. So that's going to be x squared minus 16 over x squared minus 9. So you can write it either or. Okay, that was just an easy one to, if you know your rules and properties. Okay. All right, let's keep on chugging. Number 6. Number 6 is going to be 6x plus 12 over x squared plus 11x plus 18 divided by x plus 4 over x squared plus 6x minus 27. Alright, so let's factor everything. The top left is going to be a GCF. I'm going to pull that 6 out. So I have x plus 2 over, the bottom is a Desmos or in your head. That's going to be x plus 2 and x plus 9. Ugh, couldn't get it out. Divided by, the top is already factored on that one. X plus 4 is in factored form. And the bottom, that's going to be 9 and 3. So x plus 9, x minus 3. Run out of room again. Keep, change, flip. Keep, change, flip. Now 6, we can factor that a little more. So it's going to be 2 times 3. And then x plus 2 over x plus 2 times x plus 9. Change division and multiplication. Flip that last fraction. And then x plus 4 on the bottom. Now we're going to cross some stuff out. Okay. So x plus 9, x plus 9, x plus 2, x plus 2. That's it. Now I can smush those back together, the 2 and the 3, and get 6 times x minus 3. And the only thing left on the bottom is x plus 4. Now you can distribute that 6 if you want to and get 6x minus 18 over x plus 4. So either answer is correct for this one. Okay? Alright, now 7 and 8 are going, 7, 8, 9, and 10 are different. Alright. So number 7, we're going to kick up the difficulty level just with the factoring part. That's it. But again, Desmos can help. Alright. Alright, so gotta look for that GCF first, okay? If you see the GCF, you gotta pull it out, alright? Because if you factor, you're gonna be missing that number and it might not happen with a cancellation, okay? So 9, 12, and 4, they do not have anything in common, do they? So we're gonna erase that. They have nothing in common. So since they have nothing in common, I can't pull a GCF out. You would do the bottoms up method, but you also can go to Desmos, okay? And Desmos can tell you for you. This is where Desmos saves you the most time. The other one I do recommend you know how to do in your head when A is 1. But when A is not 1, Desmos can really help you out, okay? Oops, plus 4. So this is also a fraction. This is where fractions come into play, where you need to know like your fractions and stuff like that. But also if you don't, okay, so you know, I just show you different ways. So the negative 0.6666666 repeating, if you don't know what that is in fraction form, Google it. What is 0.6 repeating as a fraction? There we go. And if you read, it says 2/3. So this is 2/3. It's a negative 2/3. All right. So that's going to be x. Remember, when it touches, it counts it twice. So that's x minus, that's a plus 2/3. Remember, you got to change it. Squared. Now the only thing you have to do is you have to take this bottom and bottoms it up. So that's really going to be 3x plus 2 quantity squared. Okay, So repeat, typed this into Desmos right here, okay? Went to Desmos, graph, I typed it in right here, okay? Right here. And then I came to the graph and it touched at negative 0.667, which means it's repeating, okay? So I Googled what it was repeating and it said it was 2/3, okay? So 2/3, so this is going to be negative 2/3. So that's x plus 2/3. So I wrote x plus 2/3 right here, but you can't have a fraction, so you take the denominator and you throw it up front, and I get the 3x plus 2 quantity squared. Okay? Same thing with the denominator. Let's type that one into Desmos. That one is 4x squared. 4x squared minus 27x minus 7. Because they didn't have anything in common. 4, 27, and 7. Well, 7's prime. That's how you definitely know. Okay. So this one is also fraction right here. You should know what 0.25 is. 0.25 is 1/4. So this is x plus 1/4, x minus 7. So x plus 1/4, x minus 7. Take that 4, bottoms it up, and I get 4x plus 1 times x minus 7. So these are little side thoughts, okay? All right. Divided by 12, 5, and 2. That has nothing in common either. So let's go to Desmos. So I'm going to do 12x squared plus 5x minus 2. That crosses, there's 0.667 again. We know that's 2/3 and we know 25 is 1/4. So it's going to be x plus 2/3 and x minus 1/4. Okay, so I come to back over here and I've got, so this is going to be x plus 2/3 and x minus 1/4. We have to bottom those denominators up. So I'm really going to have 3x plus 2 times 4x minus 1 all over 16x squared minus 1. That's a difference of squares, but again, if you did not notice that, we could go to Desmos and we could say 16x squared minus 1. 0.25 is 1/4, so it's x plus 1/4, x minus 1/4. So this is x plus 1/4, x minus 1/4, bottoms them up, and you get 4x plus 1, 4x minus 1. That's probably the hardest one you're going to see from me. This one's pretty intense, isn't it? So we're going to do the keep, change, flip. Okay, so this 3x plus 2 squared means there's 2 of them, so I'm going to go ahead and write them as 2 quantities. So I've got 3x plus 2 times 3x plus 2 over 4x plus 1 and x minus 7. Change division and multiplication. Flip the last fraction. Okay. All right, now I'm going to go through and cancel stuff out. Okay, I have a 3x plus 2, a 3x plus 2, 4x plus 1, 4x plus 1. Oh, that moved on me. There we go. So I got a 4x minus 1, 4x minus 1. So that's it. So when you smush the top, you're just going to have 3x plus 2 over x minus 7. All right, that's kind of a doozy of a one, wasn't it? All right. So number 8 is going to be just like number 7 with how like intense it is. So if you want to pause and try number 8 on your own. Cut off key. All right, still recording. Good deal. Here we go. Move on. Let's see. We got 4x squared minus 20x plus 24 over 2x squared plus 13x plus 6. Now still look for those GCFs, okay? This one actually has some GCFs where the other one didn't. 6x squared minus 24 over 2x squared plus 11x minus 6. Okay? Alright, so this one actually does have stuff in common. 4, 20, and 24 are all divisible by 4. So I can pull out a 4 on this one and get x squared minus 5x plus 6. Okay? Divided by, that denominator does not have any common factors, 2, 13, and 6. So we're going to go to Desmos, and we're going to graph it. 2x squared plus 13x plus 6. Uh-oh. Nope, there we go. Plus 6. Oh, I am just messing up. There we go. So it's going to be x plus 6, 0.5. We should all know 0.5 is 1/2. So it's going to be x plus 6 and x plus 1/2. So let's draw a little arrow. So that's x plus 6, x plus 1/2. But you got to take that 1/2 and bottoms it up. So it's going to be x plus 6 and 2x plus 1. Okay? Divided by 6 and 24. You can pull out a GCF there of 4. No, I'm sorry. Lord help me. 3. You pull out a 3 there. So we pull a 3 out. Okay. Let's pull a 3 out. And you get 2x squared minus 12. No. That's 8. Can we pull out? I'm sorry, you can pull a 6 out. Lord. Too much factoring in one day. Pull a 6 out. And 6 would give me 4. There we go. That's factorable. The denominator, the 2, 11, and 6 does not have a GCF. So we're going to come up here to Desmos. We're going to type 2x squared plus 11x minus 6. We've got x plus 6 and x minus 1/2. So this is going to be x plus 6 and x minus 1/2. Take that 2 and bottoms it up. So I've got x plus 6 and then 2x minus 1. Okay? Now, some of the stuff can be factored more, like this right here can be factored more. So while we're doing the keep, change, flip, let's get it down to its primes, okay? So this 4 can actually turn into 2 times 2, okay? So that's going to be 2 times 2. This quadratic can be factored to x plus 6. No, that's going to be a, sorry, I always do that one on this one. X minus 2 and x minus 3. The denominator is factored fine. Okay. Came division to multiplication. Flip. Now this denominator right here that's going to turn in. So then x plus 2. So then x plus 6 times 2x minus 1. That 6 can be factored more. So it's going to be 2 times 3. Now that x squared minus 4, that is a perfect square binomial. So that's going to be your x plus 4, x minus 4. Okay, so we had to factor a little bit more after we flipped it, but it saves you a little space. Now you can factor it fully and then flip it, whatever works for you, okay? So now we're going to go through and we're going to mark out some things, okay? So I can mark out a 2 and a 2, x plus 6, x plus 6. Yeah, that's all I can mark out, looks like. If I did my math right. So that's all we can work out. So smush everything. So it's going to be 2 times x minus 2x minus 3. So I just found my mistake. I knew it was a mistake. That's why I was looking at it. Alright. So I don't know why the square root of 4 is not 4. The square root of 4 is 2. This is x plus 2, x minus 2. So I can work out a little more. I thought that looked weird. So well, I can just work out one more, really. I can work out the x minus 2. X minus 2. Alright, so that's a little better, I guess. So we smush and we get 2 times x minus 3 times 2x minus 1 over 2x plus 1. Put the 3 out front, and then x plus 2, and that's your answer. Okay? And you could full it out if you want to and put it in the standard form, and you could get it. So that one's a little bit more doesn't go too simplified. Alright, so now I'm going to write number 10 a different way. It still means the same, but you might sometimes see it this way. Alright, so you've ever heard of the complex fractions? So sad thought, when you saw like 3/4 divided by 5/9, and that really just meant 3/4 divided by 5/9, and you did your keep change flip like we've been doing. So same thing here. Our rational expressions that are being divided can be written the same way. So you could have it written like this: negative 12x plus 18 over x squared minus 25 divided by 4x minus 6 over x squared minus 3x minus 10. When you see that, if it makes you feel better, just go ahead and write it like we have been doing. Negative 12x plus 18 over x squared minus 25 divided by, that just means, that's just a big division symbol is all that is. Okay? Because when you see fractions, fraction is dividing a number by a number. So that's all that is. So let me write this better. It'll let me erase. So we got x squared minus 3x minus 10. So now we can do our factoring. Okay? So when we do our factoring, I don't know why my screen's lagging. Lord have mercy. Technology is not my friend. X squared plus 3x minus 10. Alright, the 12 and the 18, they both can pull out a 6. So we're going to pull out a 6. Okay. Yeah, let's pull a 6 out. Well, so when I do a GCF, and if anytime my leading coefficient, see this leading coefficient, whoops. Jeez, Lord help me. Alright, so anytime my coefficient, my leading coefficient is negative, I pull out a negative, okay? Because usually 9 times out of 10, it wants you to do that, okay? So, I'm going to pull out a negative 6, right? And again, that's just a tip for you guys, okay? So, and when I pull out a negative 6, I'm going to divide each one of those by negative. So, remember when you divide by negative, you change the sign. So, that's going to be a 2x minus 3 over x squared minus 25. That's a perfect squared. Square root of 25 is plus or minus 5. So, it's going to be x plus 5 times x minus 5 divided by the 4 and the 6. They have a 2 in common. Do you see why I wanted to pull out that negative? Okay. By pulling out this negative 6, it made this a negative 3, which helps in a future canceling out. Okay. So it's just a tip. Anytime you usually see a leading coefficient that's negative, pull out that negative. Okay. I can factor this with Desmos or in my head. And it's going to be x minus 5 and x plus 2. Alright, so then we got to do the keep, change, flip. Keep, change, flip. Alright. Now that negative 6 I can change to negative 2. Yeah, let's change it to negative 3. Sorry, it's negative 3 times 2. And then the 2x minus 3 is fine. That's the only thing that needed to be broken down a little more. Change division to multiplication. Flip that last fraction. Okay. Now let's cancel stuff out, okay? So when we go to cancel stuff out, I'm going to cancel out the 2 and the 2. The 2x minus 3, 2x minus 3, x minus 5, x minus 5. Smush what you have left. I have a negative 3 times x plus 2 all over x plus 5. Okay? And that would be your answer. Now you could distribute that negative 3 and that also could be your answer. So you could have negative 3x minus 6 over x plus 5. Okay? Alright, so the last problem is number 10. Okay? What's happened? Alright, so this one is going to be another one of those fractions. So it's going to be 3 over x plus 1 all over x plus 4 over x squared plus 11x plus 10. Okay, so again, you can either do the keep change flip right now, or we can just keep doing it the same way we've been doing it. 3 over x plus 1 divided by x plus 4 over x squared plus 11x plus 10. Alright, 3 is prime. You can't factor that anymore. X plus 1 is good. X plus 4 is good. Really, the only thing you can factor here is that denominator right there. And that's going to be x plus 10 and x plus 1. So then you do the keep, change, flip. And I get 3 over x plus 1 times x plus 10 over x plus 1 all over x plus 4. Cancel out where you can. Well, the only place I can really cancel out is just the x plus 1s. So I'm left with 3 times x plus 10 over x plus 4. Or you could distribute that 3 and get 3x plus 30 all over x plus 4. Okay? Alright, so you have a little short study outline to do. If you have any more questions, let me know. Pause the video, rewatch it, whatever you need to do, or let me know if I need to help you anymore. Alright, guys?